Hello everybody, welcome to this chemistry series. And in this section, we'll be looking at energetics. Energetics is a topic under thermodynamics or thermochemistry. Before we dive into the definition of energetics, quickly, we all know that energy is the ability to do work, and we have types of energy. Either it's the mechanical energy, the heat energy, the electrical energy, the chemical energy. Now, in chemistry, during a chemical reaction, bond is either broken or formed, and for bond to be broken or bond to be formed, it involves energy. So, energetics is the relationship between chemicals and energy. Now, moving forward, we are going to be studying energetics in steps. We are going to start with enthalpy, entropy, and Gibbs free energy. So what is enthalpy? Enthalpy is the heat content of a body. Now, the total amount of heat that is contained in the body is known as enthalpy. And enthalpy is designated as H. Now, moving forward, when we now talk about enthalpy change, we are simply saying that it is the differences in the sum of the products and the sum of the reactants. For example, looking at this reaction, we know that in a chemical reaction, the left-hand side is always the product. The left-hand side is always the reactant, and the right-hand side is always the product. Right? Now, when we talk about enthalpy change, which is designated as this, delta H, enthalpy change is the difference in the sum of the products and the difference in the sum of the reactants. So I can say that enthalpy change is equals to the products minus delta H change in the reactants. And we know that enthalpy change from the definition is the differences in the sum of the product. What is the product? C plus D is the sum of the product minus, which is the difference in the sum of the reactant, which is A plus B. It's simple as it sounds or as it is. Now, moving forward, in enthalpy, we have two types of changes. We have the exothermic and we have the endothermic. Now, what is an exothermic change? An exothermic change is the type of change that liberates heat to its surroundings. At the end of the day, it leaves its surrounding hot. Now, I want you to think about fire. When fire is burning, it gives out heat. And at the end of the day, the surrounding becomes hot. Now, a chemical example for exothermic change is sodium pellets. Now, when you add sodium pellets in water, you see there's an explosion. At the end of the day, it leaves its what? Container hot. Another example is the dilution process of concentrated hydrochloric acid, which is also known as HCl. Now, moving forward, what is endothermic reaction? Now, endothermic change is the type of change that absorbs heat from its environment, and at the end of the change, it leaves its environment cool. I want you to imagine an ice. Ice absorbs heat from its surrounding, and that heat it is absorbing makes it to melt. And at the end of the day, it leaves its surrounding cold. A good example, chemical example, is ammonium chloride. Having seen this, let's look at the schematic of exothermic and endothermic change. So I'm going to draw one graph here and draw another graph here. Now, I'm going to number the scale as 0, 1, 2, 3, 4, 5, 6. I'll do the same here. 0, 1, 2, 3, 4, 5, 6. Okay, let's just stop at 6. Now, in a chemical reaction, know that the left-hand side is always the reactant, then the right-hand side is always the product, right? So if I have something like this, and I have another curve like this, these are two curves. Now, this is the left-hand side. This is the left-hand side. So we are trying to represent this reaction in a diagram form. So this is the left-hand side. So this is A plus B, and this is the right-hand side. So this is C plus D. Now, the left-hand side is A plus B, which is the reactant. Then the right-hand side is the product, which is C plus D. Now, what is the formula for enthalpy change? We know that the formula is change in delta H is equals to, we have the products minus the reactants. Or we can say change in delta H is equals to the sum of the product is the differences between the sum of the product. Sum of the product is C plus D minus A plus B. Right? Now, from this scale, looking at this scale, we have our AB to be 1. So we say delta H, we are calculating for this one. Let's calculate for this one. So we have delta H, this is the first diagram, this is the second diagram, is equals to, what is the product? The product is C plus D. So let's take the value for the product first. So C plus D, let's trace it to the scale. If we trace it to the scale, let's just say we are getting 4. We are getting 4. So we have 4. What about the value for A plus B is 1. So this is 1. So therefore, delta H is plus 3. Now let's calculate for this guy. Now if we calculate for this guy, we know that delta H is C plus D minus A plus B, right? So let's start with C plus D. So we have delta H equals to C plus D, we trace it to be 1. What about A plus B? We trace it to be 5. At the end of the day, this becomes delta H is equals to minus 4. So I want you to know an exothermic change, this is exothermic change, an exothermic change is always negative. Then an endothermic change is always positive. It's positive change. So this is a positive change, this is a negative change. Right? Now, the difference between here and here is known as delta H. The difference between here and here is known as delta H. Then the difference between here and here is known as the activational energy. The difference between here and here is known as the activational energy. So ladies and gentlemen, this is the schematic for exothermic and endothermic change we just defined.